Hello students, welcome to the part 4 on CAMS lecture series. In this lecture, we'll see how the displacement diagram and the gap profile can be constructed in the case of a follower which is moving with the cycloidal motion. This is the problem. We have a roller follower moving with the cycloidal motion during outstroke and return stroke. Outstroke with maximum displacement of 31.4 mm during 180 degree of cam rotation. Return stroke for the next 150 degrees of cam rotation and 12 for the remaining 30 degrees of cam rotation. Now minimum radius of the cam is 15 mm and the roller diameter of the follower is 10 mm. The axis of the roller follower is offset by 10 mm towards right from the axis of the shaft. Right? So for this given information, we shall see how the displacement diagram and the cam profile can be constructed for the cycloidal motion of the follower. Now before solving this problem, let us first understand how the displacement diagram can be constructed when the follower moves with the cycloidal motion. Now here I am taking the construction of the displacement diagram for only the outward motion of the follower, means from its lower position to the outermost position. So theta naught means the rotation of the cam during which the follower moves from its present position to the outermost position, theta naught, and this is the lift or the stroke of the follower, and with this you complete the rectangle and then you divide this into even number of equal parts, say here 6. If it is 8, it is better, right? Means you will get smooth curve. After dividing this AC into 6 number of parts, then draw this generating circle. Generating, what it generates? It generates the cycloid. So this is the generating circle, and what is its radius? R equal to stroke divided by 2 pi. Stroke is known here, divided by 2 pi will be the radius of this generating circle. Now with A as center and radius equal to this, draw this circle. Next, now you also divide this circle into same number of parts as you have divided this outstroke. That is, you have divided this outstroke AC into 6 number of parts. Similarly, you divide this into 6 equal parts. So 1, 2, 3, 4, 5, 6 parts have been divided in this circle. Now next, very important step, you project all these points 1, 2, 3, 4, 5, 6 onto this vertical line. Onto this vertical line. A dash, A is already there, and B dash. This means 1 and 2 will be at A dash, 6 and 3 will be at A, and 4 and 5 will be at B dash. So these points 4, 5, 3, 6 and 2, 1 are projected onto this vertical line. Then after projecting these points onto this vertical line or vertical diameter of this generating circle, next from A dash, before that, from A draw a line to connect opposite corner B. So just means in this rectangle connect this point and this point, opposite corner you connect. Similarly from A dash you draw just a line parallel to AB. So this should be AB. You can draw up to this BC, no problem. Similarly from B dash draw another line again which is parallel to AB. So up to this also you can draw. Then after that you have to locate the points on these vertical lines. How? Now let us say here at A dash 1 and 2 line, therefore this line contains points 1 and 2. So they will intersect corresponding lines 1 and 2 at A dash and B dash. right? Similarly, this point contains 3 and 6, so it will intersect here at 3 dash on 3, and this is 6 at here, this point, and this point contains 4 and 5, so 4 it will intersect at D dash, 5 it will intersect at E dash. So from these points, okay, on this vertical line 1 and 2 are here, so this will intersect at A dash, 2 at B dash, 3 which is here at C dash, and then 6 here. Similarly 4 and 5 are in this line, 4 at D dash and 5 at E dash. Then we join all these points with a smooth curve, which is the cycloidal motion or cycloidal path of this generating circle, or the follower moves in this fashion. Now we will be using these lengths 1A dash, 2B dash, 3C dash, 4D dash, 5E dash at C, F dash or CB for constructing the profile of the CAM. Okay. Now after having known the construction of the displacement diagram for the follower moving with cycloidal motion, let us construct the displacement diagram for this problem. Now this is the displacement diagram for this problem. Now here the follower moves outward during 180 degrees of cam rotation, and there is no dwell. Immediately it returns during 150 degrees of cam rotation, and during 30 degrees of cam rotation it becomes stationary, that means dwells. This is one complete revolution of the cam, 360 degree. So 360 degree can be conveniently represented in terms of some length, say 18 centimeter, 15, whatever you wish. Okay. Now, so this outward stroke 180 degree AS should be divided into 6 number of parts. Similarly, SN also should be divided into 6 number of parts. Mark them as 1, 2, 3, 4, 5, 6 and 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. Draw the vertical lines from each of these. Now, as there is no del between the out and the return stroke, so instead of constructing the generating circle here, we are constructing the generating circle here itself. So what should be the radius of this generating circle? Stroke 31.4 divided by 2 pi, that is 5 millimeter. 5 millimeter is the radius of the circle. So with point G as center and radius equal to 5 millimeter, draw this generating circle. Again, you divide this generating circle into 6 number of parts, equal parts 1, 2, and name them as 1, 2, 3, 4, 5, 6. And again, you project these points 1, 2, 3, 6 and 4, 5 on this vertical line, right? And then let us draw the cycloidal path during the outstroke. From G, draw a line connecting A, means opposite point A. And on this, points 3 and 6 are there. So this is point 3 and this is point 6. Similarly, draw a line from this A dash parallel to AG here. It contains 1 and 2. So hence it will intersect line 1 and 2 at B and C. Similarly, if you draw a line from this point B dash parallel to again AG, this is the line. It will intersect 4 and 5 at E and F. Now similarly connect E to N here, and this will contain the points 3 and 6, right? And this will contain points 1 and 2, and this will contain points 4 and 5. 4 and 5 intersecting at L and M. Now join all these points by a smooth curve, and you will get the displacement of the follower from the lowest position to the highest position and return position again to the lowest position. And for the 30 degrees period of cam rotation, it remains stationary. Okay. So After having constructed this displacement diagram, we shall now construct the CAM profile. So this is the CAM profile already constructed. Let me explain you the procedure. Already in one of the problem we have seen. Right now, this is the prime circle. The prime circle. What is the radius of the prime circle? Minimum radius of the CAM plus radius of the roller. That is 15 is the minimum radius of the CAM plus the radius of the roller is maybe 5 millimeter. We have to add, and then that will be the total radius of the prime circle. It is given that the roller follower is offset by 10 millimeter to the right of the center. Okay, so here you have to draw this axis which is 10 millimeter to the right of this center of the CAM, and with OS center, with whatever the offset amount is there, draw this circle which is called as the offset circle. Then connect this tracer point A, the center of the roller, to the center of the CAM O, and this will be reference for measuring the angle. From AO measure 180 degree and AOS will be 180 degree, right? So divide this into 6 number of parts. Angle AOS into 6 number of parts, and mark these points 1, 2, 3, 4, 5, 6. Then after that, return period. Again, with respect to this, measure 150 degree and you divide this 150 degree into 6 number of parts and mark them as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. Right? Now, from the point 1, 2, 3, 4, 5, 6, right, you measure these distances 1B, 2C, 3D, 4E, 5F, 6G, and transfer them on these corresponding tangential lines, right? All these which are taken from this displacement diagram, and with these as centers B, C, D, E, F, G, H, J, K, and with radius as the radius of the roller, draw circles that through each of the centers. Then draw a curve such that it is tangent to all these circles, and you will get the profile of the CAM. Okay. So finally, by drawing the curve which is tangent to all these circles, you will get the profile of the CAM. So that is the end of the part 4, students. Thank you so much. Thank you for your attention.